Okay, so for this little video, we're just going to talk about shading and how to graph inequalities. This one could be somewhat found in the systems of inequalities. All you have to do is remember wherever they meet, that's the solution set. So what we're going to do is we're going to concentrate on these two equations, and we're going to graph each one separately. I am zoomed up just a little bit because my graphs are a little bit on the tiny side. So in this first one, and again, remember, you don't have to graph using the slope-intercept form or the point-slope form or anything like that. In fact, we can use this standard form just fine. When you graph these things, what you're going to be doing is you're graphing the line, but the line itself is not less than or greater than. It is, in fact, equal to. Oops, let's get a color on there that actually works. Yep, equal to. So we are really going to graph the line 3x plus 7y is equal to negative 21. And when we do that, we can do it a couple different ways. We can solve for y if we really wanted to. But if you look, you're going to have to divide, and 3 divided by 7 is not an easy fraction. So, even though 3 and 7 easily divide 21, they don't divide one another very well. So rather than pushing this into slope-intercept form or even a point-slope form, I'm just going to find 2 points on a line because that determines a unique line. So to do that, I'm going to make a t-table, and I'm going to make it a little straighter than that. Let's try something that's a little straighter. Something like that. Yes, yes. And then I'm going to have my x-coordinate and my y-coordinate. I'm going to take a guess of one of them, just one, and find out what the other one must be. In this case, I'm going to select the two intercepts, so the y-intercept and the x-intercept. That happens, in fact, the y-intercept happens when x is 0, when you're not left or right of that the zero origin. So if y is 0, what will that look like? And as it turns out, 7 times 0 is 0. The effect is, and I actually do this, I'll take my thumb and I'll cover up the y term. Every time I do this, that's exactly what I'll do. Because in effect, 7 times 0 is 0, and it just goes away. It eliminates itself. And so that's gone, leaving me with 3x is equal to negative 21. And I just take that and I divide by 3 on both sides, and I get x must be negative 7. That's it. Okay, so let me back up here. So now that we have that point, let's go ahead and rewrite this again. 3x plus 7y is equal to negative 21, keeping in mind that the equal sign represents the boundary line that we're going to be drawing, that place or that line that separates what is solution and what is not. So now, on the same t-table here, I made y 0, now I'm going to make x 0. And if I make x 0, this is really 3 times 0, which means, again, holding my thumb up, just, oh, that goes away, and now I can just divide by 7 on both sides, and I get y should be negative 3. All I have to do at this point is just graph these 2 points. And so I take negative 7, 0, which is right here, and I take 0, negative 3, which is right here, and then I connect the 2 dots. Now, if I'm doing this by hand, then, and it might be a little bit off on this back end, but if I'm doing this by hand, then what I'm going to do first is I'm going to graph a solid line because I'm lazy. Not because there's no other reason. I'm just lazy. If we look back up at the original problem, so we get rid of what we had here. The original problem had strictly less than. If in order to find out whether or not you create a solid line or dashed line, you look at the inequality. If the inequality has a solid line under it, like this x is greater than or equal to negative 2, you keep the line itself solid. If it does not, like this 7x plus y is strictly less than negative 21, then you must dash it. So what I'll end up doing is I'll draw the straight line, and I don't do this in pen, but I'll draw the straight line, and I'll go back to it and I'll erase it to make it a dashed. So I'll just chunk it out, chunk, 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 chunk. So chunk, 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 chunk. Chunk, 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 chunk. And I do this not because it's the correct way, but because I'm lazy. So it's just easier for me to draw a solid line and to erase than it is to draw a dashed line that's straight. If you happen to have a ruler or a straight edge, this sort of thing, you go, yeah, fine. That's fine. So what this means is we cannot include the boundary line in our solution set. So that being said, now we have to figure out which side to shade on. And for that, I use a test point. This is kind of old-fashioned, but I don't do well with seeing which side of the line should be shaded, and especially when it's not vertical or horizontal, but if it's very close to being vertical, then I have a difficult time telling which side is the low side. So to go ahead and alleviate my pain and suffering, I select a point that is not on the line and I choose to test that point. If the point proves out to be true, it is a solution. Well, there's only two types of solutions we can have: one side or the other side. So if one point on one side of this line is true, that whole side is true. So I'm going to choose a point not on the line, and this point right here, 0, 0, is a nice easy one. That means that my x value is 0 and my y value is 0. So I put that back up into my original equation, 0, 0. Well, that makes that 0, that makes that 0. So is 0 less than negative 21? And the answer is no. It's greater than. So because the origin 0, 0 is false, I shade the other side. And that's it. That's shading. Now, if you want to extend this up into what are known as systems of inequalities, then what you would do is you would also graph this second one. Just for the sake of brevity here, I'm going to go ahead and I'm just going to graph this. Now this means x equals 2 is the line that we're going to go. All the x coordinates have to be 2. Y is not in the picture, so it can do whatever it wants. And it has a solid line underneath the inequality, so it has a solid line in my graph. That means that it's x equals 2, and this is the line. And so we just draw our line in there. It is solid because of the solid line underneath the inequality. And then I have to decide whether it's less than 2. Okay, well, I can just choose my 0, 0 again. So that means that x is 0, and 0 is greater than 2. No. So I have to shade the other side. And as it turns out, if I color it in purple, ooh, this area right here where the two meet, that is the solution set for this system of inequalities. And that's exactly how you do any of them. If it might make more sense later on for a slightly different inequality that you can use the slope-intercept form. But by and large, if I see them in the standard form like this, I'll use the intercepts. It's just easy. So that's one way you can do it. Hope I could help.